So in last lecture, we have seen the for loop concept in C language. For loop is useful for the iterative control statement. That means we have to use the repeated task. At that time, we are using the for loop. So most important thing, if and else are the conditional statements, and for is the looping concept. So there is difference between that. If and else are not the looping, they are the conditional statement. Go to is the unconditional statement, and for loop is the iterative control statement. That means it's the looping concept. So for loop, what we are doing in the for loop bracket, first we are doing the initialization, second part is the condition checking. If non-zero value, that means this condition will become true. If zero, then this condition will become false. If this condition will become true, then it will come to the body of the loop and it will perform this task. After completing this task, it will directly go to the here, and here we have to do increment or decrement. If I have did increment, so it will go to here. If I have did decrement, whatever the variable updated, it will go to here and again check the condition. If my condition will become true, it will come to the body of the loop. If my condition will become false, then it will coming out from the loop. Then we have seen the examples. So we are at the last, we have seen the example of add the digits of a given number. So last we have seen this add the digits of a given number. So how to add that number? So suppose my number is 123, so I will separate the 3 out of 123. So how we will separate out this? We will do modules by 10. Suppose my number is 123, so first we will separate out the 3 and 1 2. So we will do the 123 divided by 10, so my quotient will be 12 and my remainder is 3. So 3 and 12 both are separated. So here we are summing with the s is equal to s plus r, and here we are dividing that the quotient is stored here. Here my number. So number is the non-zero value is considered as a true. So it will come to here and continuously it will do addition, and here sum is the 1 plus 2 plus 3 is 6 will print. So I have give the homework print number in reverse order. You have completed this assignment.
Yes, Yogin. Actually, the everything will be same. Just we have to remove the add, matlab the plus sign s equals to. We can directly print r.
And here remove printf from here, and
Plus sum.
instead of
It,
sums
it
I will
the reverse.
translation also we need to remove, then after it will work. 321. So here also you can remove r also, no need of the r, and directly put this statement in the printf itself. I have given the one more program in assignment, that write a program to check number is prime or not. Anyone have completed that program? Write a program to check given number is prime or not. So anyone knows about the what is the prime number or not?
Starting from 2
What is exactly the prime number?
plus 1 divide, which is divided by 1
And so number, it is divided by 1 or itself only.
Yeah.
itself.
So any example which number is the prime number?
2, 3, 7,
7,
5,
11.
7.
7 is the prime number, right? So we will take the example of 7 and 8. Number is divisible by 1 and itself only. So every number is divisible by 1, right? Suppose I will do
Yes.
7 modules 1. So I will get remainder always 0. 1 modules 1, 2 modules 1, 3 modules, n number of modules. I always get remainder 0. So remainder 0, that means every number is divisible by 1. But next condition is itself only. Suppose I will do 7 modules 2. So here non-zero. Okay. 7 modules 3. Here also non-zero value in remainder. 7 modules 4, 7 modules 5, 7 modules 6, 7 modules 7. So here it's 0. Remainder is. So here it's non-zero. So what is the exact meaning of this? Number is divisible by
Number
1 and itself only.
itself.
Here always get remainder non-zero. That means that is the number is not divisible by 2. Number is not divisible, it's not, remainder is not 0. Here you can
Hmm.
see 8 modules 2 is equal to 0. So number is divisible by 1 also, number is divisible by 2 also. So 8 is not prime number,
Prime
7 is
number.
prime
Prime
number. So
number.
suppose I will do 8 modules 3. So here I get non-zero. 8 modules 4, I will get 0. 8 modules 5, non-zero. 8 module 6, non-zero. 8 module 7, non-zero. 8 module 8, 0. So here 8 is the not prime number. Why? Because 8 is divisible by 2 also, 8 is divisible by 4 also. And 7 is the prime number because 7 is divisible by 1 and 7 is divisible by 7. So write down this in your book. Then I will start how, how to make program. So I need one number first. I need one counter. Why? Counter, we need to check how many times it's 0. So we will do 7 modules 1 is equal to 0. So we will divide by 1. Then we will till the number we will check that 1, 2, 3, 4, 5, 6, 7, 8, suppose 10, 11, anything. So we need one I variable is for incrementing this number. I 1, 2, 3, 4, 5, 6, 7, 8, 7 like this.
Hmm.
We need one counter is checking how many times it's become 0. Correct? And if my counter is 2, at that time I will say this number is prime number. If my counter is more than 2, so I can say it's not prime. So I will write this code. I need one number, I need one I, and I will need one counter. Printf, enter the number, scanf, percentage %d, comma, address of number. So here we have the scan number. Then I will take one for loop. Inside the for loop, I will take I is equal to 1 and counter is equal to 0. Okay. Then here which condition I have to put in middle?
That mod is equals to 0 or
No, this condition will not
acha,
came here.
yeah, yeah, the increment.
So this condition purpose is what? How many times we have to rotate loop? So how many
Hmm.
times we have to rotate loop? 1, 2, 3, 4, 5, 6, 7. Till the number time we have to rotate the loop.
Hmm.
Correct? So middle
Yes.
condition is always how many times we have to rotate the loop. So here my condition is I less than or equal to number.
Number.
So I will start from 1 until the number I have to rotate my loop. So I will do here I plus plus. Right? Here I need one more condition. So inside the for loop, I have put one condition, that is the if condition. Here I will put if my number modules with I is equal to
Equal
0.
to 0.
If this condition will become true, at that time I need to do count by increment with 1. Okay. So once this completion of this loop, out of the loop, I will put if my count is equal to 2, then I will print here prime number.
Number is prime.
Yes, number is prime or prime number. Number is prime. If this condition will not become true, then else I will put here printf number is not prime. So write down this program. Any question in this program? What we did exactly? So for loop here the condition will always how many times we have to rotate the loop. If we need more condition, so we can use if. If is the part of this body of the loop. If is conditional statement. If is not looping concept. But for loop is the looping concept. We have put if inside the for loop. What generally beginners are doing mistake. They consider if is also loop. But if is not loop. If is the conditional statement. It is the part of for loop. Okay, I will run this code. ccp27.c /a.exe. My number is 7. So number is prime, number is 8, number is not prime. Suppose I will enter 153, number is not prime. So like this way. 2, number is prime, yes. Any other number? 4, so number is not prime. 3, number is prime. 2, 3, 7. Okay, 5 is prime number also. 6 is not prime. 9 is not prime. 11 is prime number. So like this way, you can check your number is prime or not. Okay. Next is the P28.c. Write a program factorial of a given number. What is factorial? Suppose user have given number is 4 and what is the factorial of 4? How to check factorial? First thing is
It will be 4 into 3 into 2 into 1.
4 into 3 into 2
3 into
into
2 into 1.
so 4 into 3
12 into 2, 24.
exactly. So you can do either this way 4 into 3 into 2 into 1 or 1 into 2 into 3 into 4. Both way is correct, right?
Mm.
So user will enter the number. We can start with the 1 and to reach till the number, and else we will go into reverse direction.
Yeah. Decrement the number
Yeah,
till
decrement a
1.
number.
Till 1.
Yes,
Every time it
but
will be till 1, right?
yes. So you can do either this way or this way. Both are the same. How to make logic for that? In for loop, what things I need?
Number input number from the user.
Yes, first things is the number I own. And second things we have to reach starting from 1 to 4 or 4 to 1.
Mm. Mm.
So like this way, suppose. So we will do first thing this way, 1 to 4. So easiest method. I is equal to 1 I will take and I will reach till number. So that much time my loop will rotate till number starting from 1. What I will do inside the loop?
Multiplication.
Need to do
Increment.
multiplication.
Incremented number.
Multiplication with the I. So I need suppose one more variable f is equal to 1.
Yes.
So here I will do f and here I will store inside the f. So for
Mhm.
in the starting what I will do 1 into 1.
Fine.
It will store into the f. So f will become 1 now. Next time it will come to rotate and come here. So what I will do this updated part will become here f into I 1 into
1 into
2.
2.
2 f will become 2. Then again incremented part will come here. My I become 3 and this will come here 2. So f is equal to 2 into 3 is
6.
so it will come here and it will come 6 into 4 is 24. It will be stored in the f and after the for loop we will print f. Understood this logic f is equal to f into I we have to take f is equal to 1 and these things.
Yes.
So this for the increment. We will do decrement also. First, I will write the program. Whenever you have to build a logic, first do rough work always. What things you need to do that you need to know about of that. Integer main return 0, integer I, number and f is equal to 1. So three variables I have need. I have to print f, enter the number, scanf, percentage d, comma address of number, then for loop I is equal to 1, I less than or equal to number, I plus plus. So my this loop will rotate till number starting from the 1 to till number. F is equal to f into I. And here printf factorial of a given number is equal to percentage d slash n. comma f. We will do much more programs in for loop. Then after once I will start while and do while loop. You have to do this all the programs using that loop. So because of that reason, I am considering much more programs inside the for loop only. Okay.
And Yogin, for that decrement part, we just need to decrement this. Like for instead of plus plus, we can write minus minus.
For decrement,
Mhm.
no, just not. We no need I, right? In decrement
Right.
part. So first things what we need to do. So my number is 4 into 3 into 2 into 1. That's I need
Mhm,
to do. So
mhm,
I have to decrement my number,
mhm.
not I. What I will
Yes.
do in the for
Directly
loop.
num
So
minus minus.
initialization part, nothings.
Yes.
I will
Mm,
take here number till it
mm,
will reach the 0. If
mm,
this number will reach the 0, so it will coming
mm.
out from the for loop.
Yes.
Here num
Num
minus
minus
minus.
minus.
Here I will do f is equal to f into number.
Number.
Here I
Mm.
have to do number itself minus minus
Mm-hmm.
till
Yes.
number will become 0.
Yes. Num is less than or equals to 0.
Nothing condition we have to put,
No
directly put
condition.
number, directly put number. So if
Mm-hmm.
non-zero it will become true, if zero then this condition will become false and it will coming out from the loop.
Okay. Mm-hmm.
So I will modify this code for loop. So initialization we have to do nothing, then condition my number will become 0. Till that time we have to rotate this loop. So how many times my loop will rotate? Till my number will become 0. And here I will do f is equal to f into number. So first it suppose my number is 4, then how this loop will rotate? Here my number is 4, so here it will do 1 into 4. So f is equal to 1 into 4 is 4 will store inside the f. Num minus minus num will become 3. So now 4 into 3. Then after it will come here and my num will become minus minus. So num is 2. And what is the output of this? 12. So 12 into 2 is 24. Will store inside the f. Then my num will become minus minus num will become 1. 24 into 1 is equal to 24. Will store again inside the f. And my num will become minus minus now my num will become 0. So it will, this condition will become false and it will coming out from the loop. Understood this logic?
Yes. Means here, Yogin, num is by default considered as a non-zero number. That is why we are not
Exactly.
giving to get
Suppose
give
user,
any condition. Yes.
suppose user have entered the number 0,
Mm-hmm.
then this condition is become directly false and it will coming
False.
out from the,
Out of the
then what
loop.
is the
Yes.
factorial of 0?
Factorial of zero is zero.
Any number multiplication with 0 is 0.
Zero.
So my number is 4, factorial of given number is 24. Suppose my number is 5, factorial of 5 is to 120, factorial of 6 is 720. Okay,
Yogin, can we write zero here and just check
okay,
the
okay.
terminal?
I will write 0. Then factorial of a given number is 1. Why? Because we have predefined initialize my f is equal
F
to
is
1.
one. Yes.
So we can do like this way also. If
Mm-hmm.
my number is equal to 0, then print f is 0.
Mm.
So like this way, but no one will enter the number 0. That is why.
Yes.
So you can edit your code like this way.
Yes.
Assignment for you is the Armstrong number. Suppose user will enter that number, that you have to check that number is Armstrong or not. What is the meaning of Armstrong number? Anyone know?
Sum of
Number that is equal to the sum of cube itself, its own digit.
hmm Suppose I will take example of two numbers, 123 and 153. Okay. So sum of its digits of cube, that is equal to the number. That means 1 cube plus 2 cube plus 3 cube is equal to 123. If I will get this answer, so my 123 is Armstrong number. 1 cube plus 5 cube plus 3 cube. Suppose this. then this is equal to 153, then I will say my number is the Armstrong number. So here 1 cube is 1, 2 cube is 8, 3 cube is 27. So what is 1 plus 8 plus 27?
36.
36. So this is not Armstrong number. 1 cube is 1, 5 cube is, and 3 cube is 27.
9.
What 3 cube is 27, not 9.
Yes.
So this is the my Armstrong number. 153 is my Armstrong number. Okay. So you have to do by yourself. This is your homework. Suppose user will enter, then you have to find that you have to separate out the digits. We have already did that program. Separate out the digits. You have to add one thing only. You have to do cube. How to do cube? You have to multiply with 3 times. 3 multiplication with 3 multiplication with 3. Whatever the number, you have to multiplication with 3 times. So we have did this half program yesterday. What we did, 1 plus 5 plus 3. Here you have to add 3 cube plus 5 cube plus 1 cube, right?
Yes.
So you have to do by yourself. Now next program I will make P29.c. Write a program to print reverse the bits of a given number. So here I have to not print my number in the reverse format. I have to print that bits in a reverse format. How we will do this?
The shifts operation can use.
So you have to not only print, but you have to store inside the number also. Yes, shift operation we have to use. We have to check that number is set or clear. Okay. So suppose I will do here the binary of the number 10. So what we will do first in this number, I will take my I as this position and j at this position. I will compare with my I and j. Ith bit is 0 and jth bit will be 0. Both are same, then do nothing. Here j will come here and I will come here. Here I will again compare my bits 0 and 1. If both are not same, then we will swap this bit. So how to swap this bit? This becomes 0 and this become 1. We will do complement logic. So we have already seen this. How to make 0 to 1 and 1 to 0. Number is equal to number XOR with one left shifted by position. This we already know. How 0 1 1 to 0, right?
Yes.
So using that logic, we will do this part. Okay. So here my I will come here. Sorry, I will come here. J will come here. I will come here till I less than J. Till the time my loop will rotate. So inside the loop, I will write here 4. I is equal to 0. J is equal to 31. I less than J time my loop will rotate. Here I will do I plus plus J minus minus.
Hmm.
Inside the loop, first thing we need to check my ith bit is set or clear. So how to check my ith bit is set or clear? We will use two variable m and n. M is equal to number right shifted by position I ending with 1. Yesterday we have seen this logic. So this is for checking my bit is set or clear. Number is equal to jth time ending with 1. Here we will again see my bit is set or clear. Then after m and n, we will compare. If my m is not equal to n, this condition. If my m is not equal to n, at that time what we will do? We will swap this number. So I will write down this code. Then after again I will explain this. So basic idea I have given to you what we need to do exactly. This code as include stdio.h integer main return 0. This part we have to write down first every time. Then here I will start integer. I need number, I need I need j, I need m, I need n, all the things we will use. Then printf, enter the number, operation, then scanf, percentage d, address of number. Here we will print first before reversing the number. So we will printf here. My number is before reverse bit. Number is equal, sorry, before number is equal to percentage d slash n comma number. This is my before swapping the bits, reversing the bits, my number is this one. Then after I will print the binary of that number. I is equal to 31, I greater than or equal to 0, I minus minus. Yesterday we have seen this program, right? Printf d number right shifted by ith position ending with 1. Okay, so yesterday we have seen this program already.
Yes.
So this program is for printing the binary of my
Mhm.
given number. So before my number is this one and the binary of this is this one. Okay, next
Yes.
is the commented part. Okay, then here I will do for I is equal to 0. Here I have not put the semicolon. I is equal to 0. Then j is equal to 31. I have to rotate my loop I less than j times I plus plus j minus minus. So how many times my loop will rotate? It will rotate till I less than
I
j
is
time.
less than j.
I less than j, that means it will in the between of that. Suppose I have a 31, 0 to 31, total 32 numbers. So it will rotate total 15 times or 16 times. So first thing what we need to do, ith, we have to check ith bit set or clear. And then after we have to do jth bit set or clear. That we have to check. Okay. So how we will check my ith bit is set or clear? So I will store into the m, and then after I will check my number is right shifted by ith time ending with 1. So here it will check my number is set or clear. Whatever the value of that number bit, it will store into the m. It is 0 or 1. My bit first position is set or clear. You can see here. So ith bit is set or clear. Whatever the data I will store into the m. Right here m is equal to number right shifted by ending with 1. It will give the output that is set or clear, whatever that things it will store into the m. Then after n, so n is equal to number right shifted by jth position ending with 1. Here my jth position bit is set or clear. So here it's say we are checking the 31st position, whatever the bit, whatever it's 0 or 1, we are storing in the n. Here we are not checking anything, we are just storing that data. We whatever the value of that particular position, we are storing into the m and n. Here we are comparing this. If my m is not equal to n, not equal to n, so we have seen here, see here, what if my I and jth bit both are clear, then I have to do nothing, right? If both are 0 0, then I have to do nothing. If this bit is 0, you can see is 30th number bit and here first number bit. So this is my 30th number bit and this is first number bit. Both are not same. In this condition I have to swap. If both are same, then I have to not swap that bit, right?
Yes.
I will do here. If my both bit are not set at that time, we have to swap that. So how we will swap that? So what we will do, number is equal to number XORing with 1 right shifted by ith.
Mm.
Number is equal to number XORing with 1 left shifted by position. So position is my jth and we have to do XORing with the number. That means if it is clear, then set, set, then clear. If both bits are not equal, then what we will do? If it is here, it's clear, then we have to set. If it is set, then we have to clear. Complement a bit, right?
Mm.
Here we are checking if my m is not equal to n. At that time, number is number XOR with 1 left shifted by position. So this is the logic for the complement a bit.
Yes.
And then after this completing this logic coming out from the loop, and I will print my number. I will put here comment after number. uh, After completing the loop, my number is completely reversed, or all the bits are reversed. So after number is this one, and these are the I is equal to 31 to 0, and I have to print this number. Okay, write down this program in your book from starting. Then I will run this code.
Yes.
GCC p29.c .a.exe. Suppose I will enter the number 10. So you can see my before number is 1010 and after number is 0101, and after number value is this one. Okay,
Yes.
so like this way you can do. You Suppose you have to see one by one number, so you can put here 1 second delay. Sleep 1. I'll see. If we will use sleep, then it will generate warnings, but ignore that warnings. And here, suppose I will enter my number is 10. You can see here one by one bit, and enter. So this is the visual purpose. How our bits one by one it will print. Okay.
Yes.
So that's it for today.